Hey everybody, welcome to 100% Builders podcast by Jam. Today we are joined on the show by Phillip Carter, Principal Product Manager at Honeycomb. Honeycomb provides full-stack observability designed for high cardinality data and collaborative problem solving, enabling engineers to deeply understand and debug production software together. Phillip is focused on building a high-quality developer experience, helping to drive Honeycomb's open telemetry, their open source presence, and several other developer tool integrations. If you are sending observability data to Honeycomb, there's a good chance Phillip is participating in that. For some context, we recently read a blog that Phillip authored, Improving LLMs in Production with Observability. This piece really struck a chord with us at Jam because we recently built Jam GPT, our OpenAI integration, and experienced the challenges that he outlines around failures, scenarios you can't predict, latency issues, and more. We're excited to go into more detail about this and his journey of building Query Assistant, Honeycomb's new capability, leveraging generative AI to enable natural language querying for observability. Phillip, thank you so much for being here.
Thanks for having me.
So, Phillip, you're a high-profile PM. A lot of PMs are reading what you're writing. I think we'd all love to hear the journey. How did you get into product? How did you get to Honeycomb? And what's it all been like?
Yeah, sure. So it started out playing competitive World of Warcraft from 2009 to 2011, and failing all of my college classes in the process. Apparently, I actually did learn a lot about playing competitive WoW, but it wasn't apparent at the time. Eventually, I got my butt kicked in a computer science course, had to drop because I was going to fail. I couldn't accept the fact that I had been defeated in that way, basically, like my ego was shattered. Then I started taking school seriously, worked my way through there. Then I got a job at Microsoft and I worked there for about 6 years on developer tools, specifically on the .NET stack, taking it from a kind of old Windows specific development framework to a fully cross-platform modern thing and getting into pretty much everything from pieces of the runtime to owning some of the core language design changes that we were making over the course of that journey. Programming language tooling inside of Visual Studio and just kind of the whole gamut of developer tools. And that's sort of how I've, formed my professional identity. And so then, a little after 6 years, we were pretty much successful with our initial push. And so I started looking around and realized there were a lot of cool developer tooling things happening outside of Microsoft. So, chatted with Honeycomb and I knew nothing about observability going in. I knew that there was data and querying and stuff. That was it. So then it worked out and I joined and initially spent a lot of time building up work within Honeycomb and also in the OpenTelemetry community because OpenTelemetry is this very large thing, but at the time it was starting to grow, where the idea is if you want to instrument your systems to be able to send to an observability tool or vendor to then analyze what's going on. You don't want to be tied to a specific vendor because migrating from one to the other, it's costly enough already. But now, if all your data is tied up in how they do stuff, well, you're not portable. So OpenTelemetry creates that common standard. So there's this common language for people to sort of express how operations are happening in their systems. So became a maintainer of that at Honeycomb and then started looking out a little bit more as we were, trying to grow the company in different ways, experiencing lots of different things, every company once they reach a certain size needs to do the whole cross the chasm thing, go from early adopters to early majority types. And that can be a huge challenge. And one of the big things that we found is we have great product market fit for a category of developer, but there are other categories of developers who are not familiar with observability tools. Well, I don't know what to do with this querying interface. This is kind of confusing and or scary, so I'll just not use it. Even though they came in with a legitimate problem that it could have helped them solve. They just didn't really know how to express what they had in their head into, yes, here's this thing that I can click in these boxes and type these things and click this button and then I get results that are useful. So that was part of the impetus behind looking into AI. I had actually written this paper before ChatGPT came out internally at Honeycomb. I call it a paper. It's a 2-pager, but whatever, I'll call it a paper, which was hey, we have all these problems where like the solution is probabilistic in nature. We can't know for a given user if there's like the right way, but there are many potential right ways. And if we just selected one of those, that would be better than not doing something, which is the current state today. And well, as luck would have it, there's this thing called machine learning, which is literally designed for like, here's this like space of potential solutions, and here's like ways that you can select one for a given problem. And I was really inspired actually by GitHub Copilot because I've been using that a lot for my own development work and being like, well, it's not 100% accurate all the time, but it's a lot better than not having it. So like, yeah, of course, I'm going to want something like this. Um, then ChatGPT came out and took the world by storm. And then they did their big price reduction, like 2 orders of magnitude. And this whole like take a natural language input and turn it into something in our product was like this far-fetched maybe to like, oh, yes, we can literally do this today. It is tractable from a cost standpoint. So let's go. And that's what happened. And we gave ourselves a month to create a text box where you can input, what you want to query your data with. And then it outputs a Honeycomb query that has like executed, and you see the results of it. And you see like the querying UI sort of like filled out with all the little boxes in the right places so that you can then say, oh, well, this isn't perfect, but I can just quickly tweak it and sort of go from there. And yeah, we built that over the course of about a month, and we released, and people used it in all kinds of wild and wacky ways that we could have never predicted. And we used a lot of observability practices to iterate on that because we're like, okay, 0.1, like this was great. We got a cool demo and blog post and all that, but like, how do we make this actually useful for everybody and not just a small group of people who love this? And that's where the real, like, I don't want to say the real work began, but that's where a lot of kind of like harder work began really, because it was, we had to improve a lot of things, but then also not progress on things that were already working well for us.
Can we go back a little bit? Like you mentioned something really interesting for starting the story where uh, you were a competitive WoW player. So there's like a huge community aspect to it. And then you go to work at Microsoft as a program manager working on .NET. So they have like an ecosystem and they have a community, a huge developer community. And the same thing happens when you go to Honeycomb. You have the open telemetry, open source aspect, and there's a community around that. Like, do you see any of the lessons that you learned being a competitive WoW player from the community side and applying that to open telemetry and, of course, in .NET?
Kind of. So like this one's, we try to be as nice and inclusive as we can in our communities, but like, so there's this dynamic in competitive WoW where like, it's actually rude to not be good. And so like, that's that's like, okay, whoa, that's not like very, inclusive or friendly or whatever. But like, I'll caveat that a little bit where, so if you come in and it's like, it's very obvious that you haven't done, a thing before, um, nobody really holds that against you. They're like, all right, cool. Like you're new. It's fine. We're going to take you through this and you're going to learn as you go. But then when it's time to do it the second time, you'd better have learned all those things that we taught you because like we're trying to solve this problem collaboratively and you're now a part of this solution. And if you're not pulling your own weight, you're gone. And, for like, there's casual groups within WoW where that's not a dynamic, but when you're playing competitively, like if you're not, if you're not contributing to the level that you're expected to contribute, then I'm sorry, this is not happening. And it's that dynamic I've seen actually play out a lot in some of these open source ecosystems where like, I think we're a lot nicer than the online gaming community, which is a big positive. But it does come down to like, okay, if you're new, that's fine. You're going to learn. That's great. But if you're saying that you're going to participate in this initiative and you're not pulling your weight there, like we're going to cut you down or cut you off rather. I shouldn't say cut you down. And like, I internalized that, I guess, when I was playing WoW, and that has translated, I think, to an extent pretty well in these online communities where like I knew nothing about OTEL when I came in, but I really tried to make sure that I could carve out an area where it was like, A, people were not already covering this very well, so it needed someone to do something. And then B, all right, cool, I'm going to learn everything I can about that and be kind of an expert in that area and help the broader project there. And I think that Yeah, that's literally like, we need a class, and wow, we need someone who plays this class really well. You need to learn how to do that, and with these particular dynamics in play. And if you can do that, great, you're solving a problem. Um, I think that's part of one of my bigger takeaways.
So just to hammer this point across to our audience, so when you are starting in an open source community, you want to be a contributor, you want to be a part of that. Uh, there's basically this time that's afforded to you. You come in so you can like level up, understand, and it's fair to ask those questions. But to reach that level, then when you can contribute effectively to the tool or the community that you belong to.
Yeah, yeah. And, just like in competitive gaming, if somebody is doing something else really well and there's a need somewhere different, if you try to do that thing that somebody else is doing really well, you're not going to be as good as them probably if you're starting out. So like, you're not adding value to this system. So you need to add value to the spot where like, no, this is where we need coverage. And in open source, a lot of that is very self-directed. So you don't have a manager who's like helping move you to the spot. You have to identify that spot, and you need to say, okay, this is what I'm carving out as my core set of responsibilities.
When you jumped from after 6 years at Microsoft to this really fast growing startup that was scaling, the organization was changing, the customer base was changing. You're in a new space. You said you didn't know anything about observability yet. It's a new community external to the company shape shifting, and it's miles away from a Microsoft like environment. How did you acclimate? What was that transition like?
There were some challenges for sure. I mean, I think a lot of the differences were very welcome, because there's things that work very well at Microsoft, and there's things that don't work very well at Microsoft. And some are extremely annoying, and some are things that you can just sort of put into the background. Um, I would say a lot of it is rooted in the fact that the person who hired me, who she was our VP product, um, she kind of made it clear to me in the interviews where she's like, "Hey, we have these areas that we want to go explore, but I'm not going to tell you what to do. Like, that's literally your job and why we're hiring you. Like, if you and she didn't say like, if you can't do that, then like that's going to be a problem, but that is kind of, in a way, like that's the expectation, right? And I think one of the core differences is the area that I worked in at Microsoft. Um, if you were not getting stuff done over the course of like a year, doesn't actually impact anything that matters. Now, it will have these compounding effects later on, and you'll see these, like, if organizations fall stagnant, they're fine for like 1 to 3 years. But right around that 3 year mark, it's like, holy crap, what happened? Um, that time scale is super compressed at Honeycomb, and I think probably any startup, where it's like, we got to deliver ASAP. Um, and we feel it if we miss the mark. We feel it if we're too late to something, especially because we have a good sales team that gives us feedback right away if something is missing the mark or if it's not happening fast enough. And they're like, this is literally extending the time it takes for us to sign deals. And that is money lost, basically, because we could have been working on another deal at this point. So, Mark, let's go. Um, I really, really love that. I didn't know if I would love that, but I do, because I'm a huge fan of shipping to learn and just getting things out there as fast as possible, because you want to frame things up and you want to learn as much as you can to an extent up front, to at least know that you're not going to be wildly incorrect with a solution. But you're never going to know if a solution is actually the correct solution until your users bang around on it and see what happens. And so you do that and you learn, and you have to be okay with like, okay, how do we design this thing in a way that we can pull it back if we have to, or and have it not cause a lot of damage when we do that, or shift it, or do something. And I think we try to prioritize that a lot, and that was something that I felt was missing at Microsoft, especially in a lot of things that I was doing, where it was, hey, let's just get this out there and try to get people to use it, and then excuses, and then 6 months later we're still not delivering the thing, even though it's basically ready to be delivered. And here it's like, okay, we don't have the time in 6 months, futzing around, twiddling our thumbs, waiting for this thing to.
So to fast forward us in that spirit, when you first realized, gosh, what's now possible with LLMs is going to make our customers' lives so much easier when it comes to finding nuggets of insights in their observability data. Can you walk us through that first research? How did you as a PM figure out what might be possible and get things to a point where it's ready for an engineer to work on, even for that first initial sprint where it is just about shipping something fast and being able to iterate?
Yeah. So a lot of legwork was done beforehand by some folks working on product growth at the company. So we have the sales driven side of the business, and then there's the product led growth side that has this like there's like this self sustaining motion, and a certain percentage of that feeds into the enterprise sales business as well. Um, there's a lot of different pieces to like improve that part of the funnel, but one of the key parts is when somebody gets data in, there was a massive drop off from getting data in to actively querying, and then another big drop off from querying, but like actually creating what we call a complex query. Um, and there's usually, and then on the other side of that is like if somebody creates a complex query or they do something like add it to a board or just kind of like a dashboard, um, they tend to be much more likely to actually pay us some money, whether it's, through like a very low pro tier or eventually convert into an enterprise customer. So we're like, okay, we already have these measures that we think if we can move those up, then that will have good downstream effects. So that was a way to sort of scope the problem to be like, all right, cool. This is what we're just going to focus on right now. Um, Once that price increase hit, I said, all right, this is worth trying. If natural language to a query can happen. And if basically the idea is if somebody comes in with a mental model of what they want to express, they type it out, they hit enter, and it creates a thing, cool. And it won't cost us a fortune to do that. So I went to ChatGPT and I got a hint from one of my friends who works on the Copilot team where he told me that they don't have, at least at the time, they don't have a specialized model. They literally just use the same public models that everybody else has. And it's all they have a catalog of prompts that are all sort of loaded under different contexts, and they contain different data depending on sort of what's happening. And he gave me an example of one. And I was like, oh, okay. So that gave me an idea of how I could create a more specialized prompt for Honeycomb, because a Honeycomb query is actually just a JSON object that follows a particular set of rules. So how do I take natural language and get that? Okay. I started learning here's all these pieces of a prompt that need to be able to go in there to sort of reliably produce one of these things, let alone a good thing, but just produce one in the first place. And I got it so that on a zero shot basis, meaning I just create a new chat every time, paste in a big old blob of text, and it would output a JSON object that was like, shit, yeah, that's a good Honeycomb query. That's actually useful. Then I took a step back and I'm like, all right, cool. Just putting up the bat signal. Like I need an engineer to do like an extremely low fidelity, just like throw a text box on the UI. I don't give a shit where it is. And just like, let's hook it up, and it's going to be garbage, but like, we're going to do it. And then we did that. And, it wasn't actually garbage. It was actually okay what they put together. It's not what we actually shipped with, but, it worked. And, we had a demo day because we do these weekly demo days on Fridays, and we showed it, and everybody's minds were like, excuse me, what? They're like, you could do this now? And so then it was, it was go time. Then like our exec staff were like, okay, it was like the next meeting or whatever. And they're like, so we have these roadmap initiatives, but like, I think we should do this. So like, they then asked me, they're like, how much time do you need and how many engineers do you need? And I'm like, give me 2 devs in a month. And they're like, sold. So we just pulled 2 developers from 2 different teams. One who was a little bit newer, so she hadn't quite ramped up on other stuff. And the other one, he was kind of the lead for one of the other teams, and just said, hey, you're the query assistant team for this month. And that was how, then it was go time. We like redesigned it. We iterated like wild on the prompt. We did a lot of things over the course of a month. It's amazing how much you can get done if you give yourself in a ridiculously ambitious goal to get something out there for every user within a month.
It's so crazy how ChatGPT has become the prototyping tool for every PM building with language models. When we built JamGPT, the first prototype was in a new ChatGPT session, and it was just validating that we could, in a zero shot prompt, get a response that would be useful to a customer. And so it's funny to hear that that's the same. It's really interesting in as you talk about building the feature, how much of the emphasis was about iterating on the prompt. Like when you build a non-LLM feature, the iteration of like on the UX or the performance or the copy and the product. But here it's on something totally different. Can you talk about how you sort of discovered what the prompt should be, what you learned about prompt engineering?
Yeah. So, first of all, there's plenty of good guides on prompt engineering. As you might imagine, it's helpful knowledge, but none of them tells you how to, solve your particular business problem. They all tend to have like a chatbot kind of like demo that they work through, and that's just not what we were building. But a lot of the principles were the same. Um, I think one thing that we identified pretty early on is that at least GPT 3.5 does really, really well if you give it a bunch of examples. If you try to have this like big exposition on like, here's everything you need to know and here's all the shape of everything, it kind of veers off in a weird way. Whereas instead, if you just say, here's an input, here's an output, here's an input, here's an output, do that a couple times, it tends to be like very well aligned on that. And really sort of the problem that we ended up getting into was sort of having two primary, or rather three primary pieces of our prompt. The first was rules for Honeycomb query. So like this clause cannot exist if this other clause does not exist, like things like that. This operator takes a column, whereas this one does not take a column. How do you succinctly describe that? The second is a little block of, I call tips or domain knowledge. So a super common one is when you're analyzing trace data, there's a particular field called trace.parent_ID. Holds very, very strong meaning. It's a very prominent one where if it does not exist, that means you're dealing with a root span. And if you're dealing with a root span, like 99 times out of 100, that's a request. And so the duration of the root span is the duration of a full request throughout a system. And so that's important domain knowledge that like the LLM has no knowledge about. So you need to sort of have bits of information like that to sort of say, this is what it actually means. And so when people say, I want to look at slow requests, this is the column you're dealing with here. And then finally, the list of examples, we spent a lot of time on that because there's multiple reasons why you don't want to have too many. The first is like you end up using too many tokens, and then you can run into rate limiting issues with OpenAI because, they allow 90,000 tokens per minute, and that can get eaten up pretty quickly. There's also a cost factor, but GPT 3.5 is so cheap that like it doesn't, we costed it out at like $100,000 a year, and we're like, okay, that's like 2 conference sponsorships. That's like, come on, that's not much. For the amount of value we're getting, that's not much. But the second one is a matter of accuracy. So like you need to have a diverse set of examples, but you don't want to like, it's just traditional machine learning at this point. Like if you overfit for a particular thing, then somebody starts asking different kinds of questions. It just doesn't know how to deal with that. And so there was a ton of iteration to figure out like, what are the right kinds of prompt questions to ask? Like what's like the space of inputs that people tend to care about the most? And how do we create generic enough outputs that like input output pairs that are like diverse, but also it's like the balance between generic and specific. Like if you go too specific, then it can end up creating too specific of an output for people generally when they often don't want that. And then parameterizing all of this stuff. So like, I might have an example that deals with database queries. Give me a P90, my slowest database queries. That's a very specific thing that a lot of people ask. But what if the data set that I'm looking at represents a service that is it's not talking to a database? Well, I've basically created a hallucination, right? Like I've basically told the LLM that it's okay to hallucinate and spit out stuff related to databases when it has no bearing in reality with what we're querying here. So like, how do we sort of understand of this bank of examples, which subset is the right to pull in at the right time for when somebody is doing stuff? So that's kind of some of the detail that we had to get into, and that's where a lot of the iteration was spent.
So it sounds like because of the probabilistic nature, the prompt engineering is more of an art than in science because it changes on the business problem that you're working on. It changes based on what part of the business problem you're solving for. So that's really interesting. Like, how did you see it becoming a different challenge compared to how you are dealing with regular products versus like generative AI products? Like, what advice do you have for PMs starting a role in the generative AI or the LLM world?
So I think there's a couple. There's a lot of challenges that we certainly ran into. I don't know how unique this is. I imagine there's plenty of people who have this problem as well. But we wanted to support broad class of inputs that might seem nonsensical to us. Like somebody pastes in a 16-byte hex encoded string, which represents a trace ID, and that's literally it. Like, okay, what should that be? Um, like, if somebody says errors, all right, what do you mean? Like somebody says slow, somebody literally types that. We have a DSL within the product called derived columns, where you can sort of take columns that exist in your data and you can run a computation that creates a new one. So like, if you don't have a column that represents, if user ID is less than number, well, you can create a derived column that represents that and use that as sort of this computed field that you can calculate against. And there's a language for creating that. We've had customers paste in strings of like expressions in that language and hit enter, and then it creates a query somehow. And we have a little feedback button that they click yes, and they click yes. And this is like emergent behavior. I had no idea the query assistant would be able to support this, but it did, which is kind of cool. Which I think like from a product building standpoint, really truly emphasizes like, you got to get this stuff out there and you got to get people's hands on it. Like none of us ever thought to paste derived column syntax into this text box as we were building it. And yet one of our highest paying customers is doing that literally more than once a week. Like some developer there is doing this a lot. And it's like, all right, cool. Like clearly something is working here. We had no idea, but like, if it wasn't working, in this case it was, so we didn't have to act on it, but if it wasn't working and they kept doing it, well, cool. Now we can dig into that a little bit more. If you try to spend, I think this one's true for a lot of product development, but especially with Gen AI and just the wild ways people are going to use this thing. Like if you try to spend all this time up front trying to figure out all the right ways that it's going to work based off of these inputs, you're wasting a lot of time because you're not going to be able to account for what people are doing. And you're far better off looking at what they're actually doing, noticing patterns and adjusting from there. And from like how you do that is, I think, where there's a lot to be learned in our industry. So, I wrote the blog post talking about how we apply observability principles to this, where we track like inputs, outputs, model errors, and like our own like parsing and validation errors on those model inputs. And we can group by different things that we actually have about 24 fields that we instrument. So we can group and filter arbitrarily on all these different things. And you can very, very quickly, after about 24 hours of usage, you can take that slice of data and you can just sort of say, okay, I'm going to order by this thing. And then, you can see, oh crap, looks like the most prominent kind of error is related to when somebody asks some variant of the question, what is my error rate? And it's like, oh, it's emitting something that's an invalid query. And I can see why the LLM might have done that. So that now informs how you can take that problem into prompt engineering and say, okay, this is a specific problem we're going to go and try to solve. Once you get into the prompt engineering, it starts to really get into uncharted territory, I think. There's really no good tools out there. Like, there's no like VS Code plugin that has amazing tooling features for prompt engineering. There's not really any good tools for tracking versions of prompts. So like, you have a version that you went live with. You have this other version you're developing with. How do you know which one is better? How do you know when you're going to swap to the other one? Well, you could do like kind of what we did is we used a GitOps principle where we have our own repository for prompting, and we tag when we're like, all right, this looks like we're going to take this one live. And we track like, okay, this is the version of the prompt. We pull that like literal tag version into our actual main repository. And then we also have the version of the thing that we stamp in there. So we say, okay, cool. Like we know which one we're working with here. So that's another bit of data that we can operate on. But that's still all very, very manual. Like, there's no good way to integrate that with the rest of our development lifecycle. We had to create that on the fly. And even then it's super rudimentary, like file in one repository, literally copy paste into another one. At some point, we even copy pasted the string of one into a launch Darkly flag. So launch Darkly's flag supports strings. And our prompt was small enough to fit into the string. So we literally just loaded it up as a feature flag once. It worked. So don't knock it if you haven't tried it. But like, it's a total Wild West out there. And I don't know how much on the product side you can really influence. Like a lot of this is like developer tooling that needs to be built to support this. But I think it's almost sort of like a systematic mindset of understanding versions of things you're dealing with and general inputs and outputs, and also tracking information like, hey, at this point in time, it was designed to solve these kinds of problems. And so then, like, you worked on another thing. Let's say you built another version of your prompt, you release it, your users aren't as happy with it. Okay, well, what's the difference between that one and the other one? Well, if you look at the English language text, maybe you could sort of figure it out. But like, how do you know what your mindset was into developing this thing you thought was better was actually worse? Um, there's again not really a good way to track that sort of stuff, and so you have to sort of have a best effort. But like, you can track it to an extent. You're just not going to have built-in tools for that. Um, I don't really know if it falls on the product manager to sort of like create that system, but I think one of the jobs of a PM as an organization is to like instigate things. And you're like, all right, cool. We are lacking good tools that make our developers happy for this. So this is just what we're going to fucking do. And there we go. That's how it's good. That's how it's going to work. And like, you don't have to sort of throw your hand in a way. It's sort of like involving yourself in the development process, but like, it's not code, it's English language text. So it's easier to understand if you don't have a software development background. But like most PMs are pretty good systematic thinkers. And so like you can think systematically about this stuff in a way that'll make sense for developers.
I'm curious about one part that you mentioned where there's no concept of prompt versioning when it comes to like the development lifecycle. I want to learn a little bit more about that because when I think about building like general software, not like generative AI, the way you basically track, the versioning is you put out some production version and you can go back to GitHub or your CI tool to see what version is actually out there. And then you can match with some sort of like ID that you would probably uh, have like of the code that's already running in production. Like, can you not do the same thing with like the prompt versioning? How is it different from the status quo?
You could, you have to set it all up yourself. So it's sort of like if you're vendoring your own software development library. So you have one part of your organization that builds the library that the product uses. So like, okay, that organization needs to properly manage the life cycle of this library and like clearly communicate to the team, okay, like these are the changes. This is what's happening. This is how the package gets distributed. This is how you go and understand what the changes are and all that kind of stuff. Um, I think the key difference is there's a lot of really good tools in that space for larger development teams to do that sort of practice with libraries. But there are as far as I know, there's not really many tools out there, if any at all, for prompts because it's just these text files that are like kind of like SQL scripts, but weirder and a little more different. Um, and but there's also no like, 3 decades of SQL database management tooling to sort of like validate a whole bunch of different stuff. And so you have to go and create it yourself. And so like, yes, you can do stuff under source control. You can have these text files under source control. You can build your own versioning system. You need to figure out how you're going to distribute this stuff across different parts of the organization. If it's all the same team, it's easier, of course, but like for larger enterprises, they're going to be running into this where like, I can totally see it. There's going to be prompting teams and there's going to be like, integration teams and all that. Um, and there's no way to like, you set it all up yourself now. That's creating a need. There's going to be teams that they'll build specialized like SDLC systems for like prompts basically. But right now, yeah, you kind of have to build it all yourself.
It's so funny. It's like products pre LLMs. You spend, let's say you have a month to build it. You're spending that whole month like putting the UIs together, I guess, and the data flows between them. And then products with LLMs, the UI is really basic because it's going to be something open ended like a text field. And then you spend the month iterating what comes out after you put something in the text field. What it sounds like for you, what you found is you could only get so far on product quality with an internal testing team. But actually, because the edge case space is so broad, you really needed to ship fast and start getting feedback externally. So customer feedback and quick customer feedback becomes existential to the product's quality. For PMs listening to this who are about to launch a first iteration of their LLM based feature, what is the playbook that you advise for how to instrument their product so that they can do what you're suggesting, which is get really quick feedback that it's actionable, that they can iterate the prompt on and keep improving?
So there's a lot of things you could potentially add. It kind of depends on how complex of a system you're doing. Um, at the most basic level, there's almost a prerequisite. So I would highly advise, unless you're building, I don't know, maybe a chatbot, but arguably then I don't think you should do this, but I would highly advise not just taking the output of the LLM directly and throwing it right at the user. And there's a lot of good reasons not to do that. There's, if you can control what the output is to some extent, you can usually make it a little bit nicer. You can do better things, certainly, like it's just text, right? So like, you can parse that text, and like ChatGPT does that, right? Like if there's a code sample in there, it'll render the code block differently than the text and stuff like that. So like there's ways that you can sort of take that so you don't just throw the LLM output at them directly. I view that as a prerequisite. If you're not doing that, you need to stop and like kind of probably do that. But then once you're there, you now have 4 important things that you can track. You can track for each user interaction, each request, you can track an input, you can track the LLM's output. You can track if there was an error or not, and like what it was with like the LLM output. And if there's an error, you can also track, like if you're parsing and validating stuff, what that error is. That like, I think a lot of use cases are going to end up producing some sort of structure that needs to conform to some rules. And whenever you want to parse and validate stuff, there's always rules like, hey, we're going to check this rule. If it fails, all right, this is the name of the failure that's associated with like that rule. Now you're really starting, now you have some good data, because you can group by errors. You can even group just by outputs directly. And be like, okay, for like these class of outputs, what were the inputs? Or like for these class of inputs, what were the outputs? The error case is often the best to sort of start with, because like it's going to screw up. And so, you don't, before you get to like making sure it produces the best possible outputs, you want to make sure it like actually produces outputs in the first place. So there's patterns for like, okay, if the large language model failed to produce a structure that we were looking for, like it said, I'm sorry, as a large language model, I'm not capable of blah, 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 blah. Right. Well, like that's going to produce like a parsing failure, basically, because it's just like, in our case, it was not a query. It was just some random string. So we can look at that and we go, okay, like what kinds of inputs are people asking? And if you group by like that output with an observability tool, or, even a lot of logging tools support this, you can very, very quickly identify, okay, like a lot of people are asking stuff related to error rates or slowness, or, whatever domain fits your product. And that gives you something tangible. And then when you do the inverse, when you start looking at inputs and you look at frequency of inputs, you're going to find there's definitely a Pareto distribution of inputs where like most people tend to ask the same kinds of questions, or rather those are the most numerous kinds. And then there's a drop off, and then there's the super, super long tail of really unique ones. And you can say, okay, well, based off of those, we're going to try to fix those class of inputs or try to make those as good as possible. And then, as you're iterating, your solution is going to appear as if it's a lot better. The other thing is what that allows you to do is, especially when you have like a parsing and validation system of the outputs, a lot of those can actually be fixable. One thing that we found with OpenAI is very often in our initial release, it would output something that was like 90% correct. And it was like, yeah, I could see why it would do that actually. Like if it was a human back there, like writing out the thing on a piece of paper and handing it to me, I could be like, oh yeah, I could see why they actually made that decision. A lot of those are manually fixable. And so you don't need to go back to prompt engineering and go through this whole thing. You can be like, oh, well, it failed this rule, but it actually has all the information it needs to like be a valid thing that we're trying to produce. So we're just going to correct it and make it seem like the AI model actually produced the real answer. Even though it didn't, it just provided most of the answer. And that's where like, there's a bit of creative thinking involved, but like you can't really start approaching that mindset for how you're going to deal with this stuff until you have that data of like inputs, outputs, errors from the LLM, errors from your system that deals with outputs from the LLM. From there, you can do more. So like we also have a thing where like you want to query a schema, like a big data set. Well, that schema could be enormous and it could be too large to fit into a single request. So we use an embedding system that then embeds these things as floating point vectors. And then we pull out like a most similar subset. And then that's the only data that we feed in. Well, like that subset, you can capture that as input and you can say, okay, for like if you scope it down, you also have information. This is the user, or this is the team, or like, whatever identifying construct you have that represents the thing. You can say, okay, now we're scoping down to a specific customer who's using this a lot. And it turns out this data is um, being cut down in this way. And is that good or bad? Well, you can make that judgment call based off of what you're seeing in your data there. And then if it's good, okay, cool. Like, why is this still causing a problem? And that's like, yeah, this is kind of like an observability. I don't like the word observability driven development, but it's kind of like you're using observability data to sort of like drive what you're going to go do next. And like, you can't really like, I'm just convinced that you can't really do this effectively unless you have it out there live and you have this data of like, all right, over 24 hours, these are all the customers doing all this wild shit with the thing that we built. And here we go. This is what's going to happen.
So it's like one of the cool things about the way that you've instrumented this is that the output is basically JSON, which means you can validate it, which means you can have this extra step in between what the LLM returns and what you're going to show in the UI, where you can get critical insights on your product quality and then update the product without being reliant on users even giving you feedback. Is there any part of this that you recommend product managers instrument so that they get like qualitative user feedback or user feedback of like, was this response helpful? Did you do any of that? And what have you found is helpful versus sort of hard to action?
Yes. So we do have a little thing. So like the Honeycomb querying UI, there's like the text box to enter your stuff. And then there's like this part of the UI that's kind of like a visual programming language in a way. You can like click in these boxes and select from a drop-down list, like these columns and stuff that represent a query. And when you do the query assistant, it fills in that other part of the UI. So like it didn't, the manual query, if you want to go and update it manually, because like it's mostly right and you just want to quickly change something, you can just go and do that. You don't need to write out everything yourself. And then you have at the bottom of that, you have the results. And the results is like there's a graph, and then below it, there's a table. And right above the graph, there's a little banner that shows up. It's very small. And it says, here, like, this was your input. Did this answer your question? Yes, no, unsure. Click the button for yes, no, or unsure. So as you would imagine, for any feedback system, it's something like about 15%, 20% or so of those query executions end up with somebody giving us feedback. And of that, like I talked with a UX researcher about it, and he's like, yeah, like more people, like they're more likely to respond with the feedback if they have a negative experience. And so like people who got what they wanted, they might not even notice the box in the first place. And so like, we had an initial like 30% yes, about 15% unsure, and then the rest was no. And so that was an additional field that we could group by. So like of all the class of inputs, scope it down to the ones that actually had feedback, and then start grouping by yes, no, or unsure. For like a 24-hour slice, it's not going to be representative, or it might not be representative, depends on your scale, I guess. But after a week to a month's worth of usage, you can usually have like, okay, if we scope it down to only those with responses, then you're going to have enough of a representative, like diverse set of like inputs and outputs and stuff like that. So the same thing I talked about before, you can just apply that now with like yes, no, or unsure. And you can say, oh, the ones that said yes, what was it about it that worked? And like you uncover weird stuff, like the output, you're like, I don't think that does a good job, but they thought it did a good job. So I guess I'm not going to complain. And then, for the no ones, you find a lot of cases, at least in our case, a lot of times where it was like actually kind of close to something that could work. And I could be like, hey, I could see why somebody would say no to that, even if it was actually pretty valid. And so that, again, that's another, like, I think once you get past the whole sort of like error problem space, now you're dealing with how do we make this as good as possible for these different kinds of people. This is where this data really sort of helps on the quantitative side. Now, on the qualitative side, I think Honeycomb, we're a little bit lucky because we have a community Slack channel where we have some end users who are like, they're not representative insofar as like they're kind of like power users, they're enthusiasts, that kind of stuff, but they're also really, really good at giving us feedback. And sometimes they're also champions on their team. So like one person, he's an observability champion. He's like, hey, I was using this pretending like I was one of my team members who I'm starting to onboard. And I didn't like this, and this. I thought this was actually pretty close though. And we just worked with him directly to be like, all right, keep like putting yourself in those shoes. We were able to get him to basically give us the thumbs up to be like, this is like twice as good as it was before. It's still not perfect, but I feel like this would actually help me if I were in it. Um, and I think if you don't have those systems set up, like you need to have that for sure, or at least have like a direct line of communication with some customers who you can trust are going to be very honest with their feedback and are going to be like good product minded people as well too, who can take a step back and be like, okay, if I think about myself as not the current role that I'm playing for my organization, this is how I would think about it. Um, and I think we have people who give us that feedback, but yeah, you're going to need to go and solicit that directly if you don't have people yelling it at you already.
That's super helpful. Philip, shifting gears a little bit, we're all builders. People who are listening to this podcast, they're also fellow builders, and we love to know about the tools that get you up to speed, level you up. What are some of the tools, both Gen AI or LLM leverage or not? What are the top tools that you're using right now to level yourself up as a product manager?
Um, so certainly on the Gen AI side, Chat GPT, it I said it again, like it's a good prototyping tool. It's combining that with the various guides that you can just sort of read online. You just look for prompt engineering, you're going to find like 3 or 4 websites that have a lot of stuff there. Running through some of those examples helps you develop a bit of a sense for things. Um, I think there's a couple other things. It's not really I mean, I learned all of this through like college statistics, but like understanding some degree of statistics and like growth PMs will be really good at this basically, but other PMs who are not growth PMs, like developing data literacy and understanding like what it means to have representative sets of data, what it means to have sampled sets that are still good. Like, like all of this, you can't really build a good LLM powered product unless you understand you have this kind of data literacy and building that up. Like I would say the kinds of things that someone who's a growth PM it needs to learn to be effective at their job are going to be extremely similar. Anybody who has an ML background, if they came from that and they're now in products, like they're going to be great at this sort of stuff. Um, some degree of programming as well. Like I know that a lot of PMs don't have a programming background, and that's totally fine. They're great in other ways. But like there's a big difference between using ChatGPT and actually using the API that you're going to put into production and knowing how to crack open a Jupyter notebook with a little bit of Python code. And you don't have to be great at it, just enough to like call an API and get it to the point where you can like, all right, this is my box where my inputs are going to be, and I'm going to hit shift enter, and then it's going to output the thing in this other box. And I'm just going to keep moving along with that. That's really important. So like learning Jupyter notebooks, learning unfortunately, the hell that is installing Python onto a machine and not screwing things up. You can get help from a developer with that. You don't have to be all on your own. But learning how to use some of those tools, because like I got them saying like prompt engineering, no tools, all that kind of stuff. But like there are tools for machine learning and iterating with data sources and stuff. And you don't have to be an expert with them, but even at a really basic level of like, okay, how do I use this stuff so that if I want to chat with someone who does ML or someone who, a lot of companies are hiring ML contractors to like help them out with stuff. Like this is the language that they work in. And if you don't have some framing or understanding of how to do stuff in that way, it's going to be really hard to get a lot of value out of working with these kinds of folks. And so, you don't have to go and become a software engineer, but if you develop like the equivalent of, if you took like a college course in Python programming for like the first 2 months or something, like that amount of literacy of using the language and some of the tool set, particularly with Jupyter and calling REST APIs and maybe even the OpenAI client Python, that's going to be really, really important, I think. Because then you also have an artifact you can take to your developers where you can be like, hey, cool, take this, and they can execute it and be like, okay, I see how this is working. It's a lot better because as great as ChatGPT is, it is different from their API because it's several machine learning models sort of layered along with one another. And if you get something working well there, and then you say, okay, developers use the API, they're going to be like, this is not outputting what your thing was outputting. And like, you don't want to, you want to discover that beforehand, basically.
So this happened at Jam too. When we were building Jam GPT, the first prototype, the MVP was in ChatGPT. And when we went to go use the API, it was all different. And that's because there's a set of system prompts and they wired things up differently. And so the first thing we did is we got a Jupyter notebook where I, playing PM, could futz around with the API. So if product managers are listening to you thinking, okay, this is a whole new like hard skill set that I need to learn in order to stay up to date with what's now available, learning a bit of Python, learning a bit of statistics, learning a little bit about data. Are there any resources you recommend for PMs to start reading up, learning?
I think one of the best ones that I came across, which I did run through, even though I kind of knew about prompting at this point, is there's this short course. It's like a day-long course done by Andrew Ng and one of the engineers at OpenAI. That's called Prompt Engineering for Engineers, I think. I don't know. We can get a link to it in the show notes. Um, but you really don't need to be a software engineer to do this. Like they have like an online Jupyter notebook environment already preset up for you, and you just work through some examples, and they encourage you in these videos to be like, hey, so if we tweak it this way, this is what comes out. And then like you get your mind going, and you're like, oh, what if I tweak it a different way? Let's see what happens. And getting into that experimental mindset there, I think it's a nice like clean room environment where you can learn how to do this stuff. Um, and then you can take that and translate it like, okay, I want to do this on my own now. So now you're perhaps a little bit more motivated to go through the like, don't want to underestimate the hell that it is to set up a Python environment on a machine that you might not already have set up. Like it's worth that pain now because you kind of have your head oriented around this a little bit. I would say like, there's a lot of books on statistics, a lot of books on understanding data and stuff like that. Um, I'm really big on getting your hands dirty and just trying things out. And I don't know why I didn't mention it earlier, but yeah, that's like the one thing that I would say. Try that out. Try out the day long course. It's short. It's free. It's done by experts who really know what they're doing, and they teach you a lot of things that are like can get your mind going with like different ways that you can experiment beyond just what they show you how to do.
Philip, this was awesome. Before we say goodbye for now, any books you would recommend for people? Just books that helped you in your career to level up or start your journey, or books that you're reading that you want to give a shout out.
Well, this is fun because I never read any PM books and I never learned how to do PM like, the Marty Kagan or whatever. So like I've literally never read any of these people's things.
Are you saying you are never inspired? Just kidding.
I might
Just
be,
kidding.
who knows?
That's the name of the book.
There was a book that I was recommended. Don't remember it off the top of my head even. I didn't even read most of it. I just read some of it, but it was an old school Microsoft PM book. It was about it's like how to get stuff done or something like that by like is the guy's name Scott Raccoon. I don't know. He was a PM on Internet Explorer in the 1990s, and kind of all about like a lot of the information in there is frankly a little bit dated, but it is sort of centered around like your job is to get the right thing out to people as quickly as possible and iterate and work with customers and work with stakeholders. And like, um, there were, there was really no formalities or processes sort of laid out there. And I kind of liked that. I think another thing now that I think about it is that there's a lot of blog posts written by another old school Microsoft PM. It's his website. It's called Joel on Software. He's one of the people who co-founded Stack Overflow. And so he was a PM on Microsoft Excel back in the early 90s, like before, now Excel literally runs world governments, right? But like before it was doing all of that. And he writes a lot about developer stuff, but he does write a lot about like whole product sort of thinking and, just like I don't know, like helping create a mindset um around how to solve really, really hard stuff because that's like the problem space that he was in and how, it's really not magic. And there's a lot of dynamics that go into it that you can influence and others that are like, here's groups of people that will actually prevent you from doing the thing you want to do. And here's like how you deal with them. Like his classic is the software developer architecture astronaut, which is even a term that he invented where he's like, oh, there's these developers who will spend all day trying to think of the best possible way to do the thing, when all you need for them to do is to just write some damn code for like, a day and then get something out there and like, we'll work with that. And he elaborates on so many different things. I read a lot of that. And I think that that helped me develop a lot of mindset, especially when it came to working with a variety of R&D teams.
I love that.
Philip, this was awesome. I learned a lot.
Thank you so much for coming on. It sounds like, if I were to wrap, if you're a PM and you're thinking about how do I level up and start and become a PM that can work with these new technologies, you can't be afraid of customer feedback. Customer feedback is essential. You can't be afraid to ship fast because the iteration has to happen after you ship for this type of product. And there's a lot of data, statistics, and programming that you need literacy on that you didn't in the old world, but do in the new world. Anything you would add?
I think that about covers it. I mean, I think the last one is having an experimentation mindset of being able to think as creatively as possible about trying out different things and seeing what happens. And it's okay if it kind of screws up sometimes, is essential in this one.
Hell yeah. Philip, thank you so much. Have a great rest of your day.
Thanks for having me.
Thank you, Philip.